Boy, guys, we're in the middle of a grow season, in the middle of a hot season, man. And there's so much going on I got going on outside. I'm gonna turn this fan on. I'm hot. Anyways, I've been working out in the garden all day. It's supposed to get some rain. Well, it never showed up. But we're gonna. I got this jb-1ss that won't pass no RF. So it's got, I'm pretty sure it's got a blown transistor in it, but I gotta go in. We gotta go in it together and find out. I figured it'd be something y'all would enjoy watching. So we're going to start by getting into the cabinet. jb-1ss by Black Cat, Wawasi. This is the transistor version. Oh, that feels good. I finally got to test it out the other day. When I went to put RF for it, it won't pass RF, and I tried to tune all the caps. I can't get RF to pass. It's got a decent input tune, but what it's doing is knocking the signal on the transmitter down, and it won't pass. So I'm pretty sure it won't make no power. I'm pretty sure it's got a bad transistor in it, and we're going to go find out together right here on YouTube. Alright. Obviously, this one's going to be pretty crude. We're going to have to remove the board. We're going to have to remove the switch. So the switch, 1, 2, 3, 4 screws. These 2 leads will carry. We'll be able to pull the board out, work on the board, desolder the transistor. That is going to be soldered onto the underneath side of the board. All right, so with that being said, we need to start at the switch. We're going to hold that switch. That'll need to be out of the way. Now we can get to all 4 of our board screws. Let's see. So if I can get these nuts to come off. Then we'll get our squeeze washer. And we're going to do that 4 times. Because these screws are going in through the metal aluminum cabinet, they can't turn because they're threaded into that cabinet. So it allows us to remove the nut and star washer from one side. Now I hope the little transistor's good. We can find out that we got something else going on. But the characteristics of what I was seeing tell me a little different. Alright, this one here is meaning existence of the screwdriver. Oh, not that one. There we go. Alright, now we can lay this back. We don't want the screws to fall through, in case they do. Now we're going to get this one. Alright, so we're pretty well into the device. The device will be screwed. Now we're going to come here. All right. Beautiful. Back over. Okay, there's pill screw one. Pill screw two. Okay, we should have a feeder, which typically will be one wire going to the relay here. All right, just like that. Okay, now we're going to desolder. Oh my God. That might be why we don't have no RF going into it. Guys, I think that wire was broke. I don't think I just broke it. I think it was broken, guys. I think I just found the problem. Well, that's great. Because what's holding it is the two white wires. So let's observe this circuit. Guys, I really think I just found the problem, but that's good. We can put some. No, I cannot believe that's been done. I've got a tester. Absolutely no heat sink compound. Strictly relying on connective pressure. So this transistor's probably blown now that I see this. There's absolutely nothing, and I know there's not a heat sink really, but they've just scratched it. When I turn it over, there's no heat sink on the back of the pill. Or no heat sink, no compound. But when I look, this wire wasn't even connected. And if it was barely. So what we're going to do, obviously, we're going to pull these pill screws. And the way this works is everything is so tight on this amplifier, you're going to have to push them out. And then they still may not come out if you don't have them just right. See, this one may not come out. It will, it's just going to be difficult. If it don't come out perfectly, let me look at this. Can we push it over just enough? What's it? All right, we're gonna have. So that one ain't coming out. That's what I'm trying to show you. So we'll lift. Wow. I like the fact that emitter base collect. I like the layout of the board. It's nice. We don't see any blown traces. Let's get this screw. Oh, that's not a screw. That's the tuning capacitor. Yeah. Tuning capacitor. Okay. So, this wire pill screw, this wire, which comes from, should be this leg right here, which is positive. Okay. Beautiful. Let's desolder that wire. And let's put us a wire on there of proper length. Because regardless, even if we have to put a new transistor, which I have some, we're going to have to replace that wire. Or at least, and it's a little short. So let's desolder it. And we'll get it off. Then we're going to lift one leg of this transistor and we'll test. And if we get a good testing on the transistor, then we know, more than likely, of course we'll clean all this up. Everything looks good. We know the keying circuit's working. Everything looks good. We don't have any open traces. So I think I found the problem right out of the gate. I'm going to clean this up while we're waiting on the gun. Let us get in here and there's base over here. This is a collector across from the base. And then both of your emitters. Back to the base. Clean around the relay. We're going to reflow the entire board. Since we're in it this deep, right around the keying circuit. We're just going to clean this entire thing up. Because this is a collector. This is something I'd like to get fired back up. All right, so this is going to be simple. Absolutely simple. I believe, anyway. It's using a T60 package, which is in your NPNs. T60 TP60 package, which is like a 2222. Beautiful. So all our conductors are good. I really think our problem's right here. 99.999% sure. Relay looks good. Coil looks good. Obviously, we have to test the transistor. Both of our loops and our shunts. All right, I'll flip it back over. And what I'm doing now is just determining the safest way to do this right here. All right, so let's jerk the key in circuit, or the relay feed. Give it a little bit of solder. Always give a little before you remove. So we'll come in here. Pull vacuum here. I'm working with pretty excessive fan above my head, so you might have to where'd it go? Break. Sure did. Beautiful. So we're going to go ahead and remove that little broken stub. Stay with me here. So now what we're going to do is remove the broken stub, a little broken wire that broke off the end of this, which is right here. There it is. You see it come out? So it's right here. That is actually what happened. So that is more than likely our issue. So this is a solid conductor that feeds the relay. Well, our problem is we were keying the relay, but we wasn't getting any RF. Well, the relay was getting shunt because what happens is the relay gets grounded. The keying transistor gets grounded. The relay closed, and the RF couldn't get through the circuit. Now, with that being said, there's the end. See, this is broke. That's going to be real simple to figure out. It broke off that feeder. Right there. Okay. You goofy motherfucker. In, out, and then the out. Now out's now. Okay. Okay, there it is. I see it. Broke off. So there's the in. Motherfucker, I watched you break off right in front of my face. And then the brown. That goes to the feeder. I'm gonna draw me up a schematic here for a second. That goes to the feeder. That obviously goes to the output. Hang on. We have to lay it out to see, because if that would have ever reached, hang on a minute. They wouldn't have had that in there that tight. They would not have had that tight. It's not possible. All right, so that goes there. Right there. Which just fucking broke. So we'll fix it. This goes to the output, to the SO239 connector, or to this one. Oh, I just don't believe that would have. And they're both outputs. So brown. There's how it goes, right there. And then the brown feeds it. Yep, that's it. Now hang on a minute. Okay, that's that cap leg. Okay. And then the brown. All right. And then that feeds it. Okay. And then this is the okay. I'll tell you what we'll do. Get that brown. And that goes to the other side of the shunt. Or the diode. And this is a diode. Protect diode. Alright. So we're going to wait. I'm going to label this. Well, we don't really need to. This output, or input, excuse me. Okay, let's make up our I'm not see that forward. There it goes. So now they've all broke. Okay. That's alright. That's what I suspected was going to happen. And that needs to work off the bottom. Alright, so that's the input. And this one broke all the way off the bottom, goes right there. Let me draw this out. There. And yeah, we got a bunch of broken wires, so we're just gonna have to rebuild it. But let's see, there, and then the straight shot goes from here. Me fucking weird, dude. Middle one. Yeah. Yeah. That's the negative. It's the positive side of the cap. All right. Good God Almighty. Wire junkie. Another one more. Looks like that little wire. fucking gotta be real careful because the hard wire, this shit breaks off easy. It's starting to piss me off. All right. So now we're going to fucking ridiculous. Come on. Ridiculous. Thank you. I about got it memorized now, so now we can clean this. Take your knife. You want to scratch till you can see copper. And once you see copper, we can tin it up. There we go. We're not going to worry about it yet. Now we're going to take SO239 input. I really shouldn't have put that on there because it's going to piss me off trying to get it off. Watch. But I couldn't resist. I couldn't chance making him a son of a bitch. Got it. You know what I'll do? Let me have that damn. Let me write. Yeah. Right. On my front. This one will come. Into center. Let it go. All right. Center. All right. So what I just did is labeled everything. Now we got a fish. That fucking pisses me off when I do that shit. I knew better than to do that when I put that shit on there. I knew the second I put it on there, it was going to piss me off. I mean, I knew the second I put it on there, I was going to get pissed trying to get it off. I mean, you can't get this shit off. Makes me so mad at myself for putting that shit on there. Why did I do that dumb shit? That was stupid. And I'll admit it right now. That was stupid. Putting that tape on there. The way I did it anyways. Taping it back to itself. Now it's like I'm going to have to peel every little piece of it off. Nonsense. Don't do that shit. Look at that. Oh, this is pissing me off. I can't believe that. Got me so fucking mad, dude. At myself for doing that stupid shit. My God, Justin, why did you do that? That was dumb. God. 20 minutes trying to get a piece of tape off a wire for nothing. Because my dumbass wanted to put it on there. Oh my God. It's got to fight me till the very end. My God. Don't do that, guys. Alright, here we are. Now we're going to run this. Now I'm going to turn it around, solder it where it goes. Now we're going to turn this, put your damn tool, 180 degrees, just like it's supposed to be. Get a piece of tape out of there. That damn tape wants to stick to it. Alright. These aren't really easy to work on because you don't have room. Like, it doesn't matter. I mean, I work on a lot harder shit. So, now this is going to go. Let's wire that one straight. All right. So that one will need, let's go inside that capacitor, Justin. We're going to need to be right there. That'll go right there. That's our center wire. Goes right to center. And then our feet. All right. And then our SO. There it is, input. So we're going to put this I know that it don't really matter because they're both soldered to the same point. It doesn't matter. They're the same wire, so it's the same circuit. Doesn't matter which way you do it because it's going to the same place. So let's do this. Kind of have to think it through because once you solder it all up, you can't move it. And I won't want to make any links longer. We're going to go ahead and make the center tap up. All that is the modulation light. So I'm going to cut it about right here. Make it a little long for now. We got our output to our SO239. Let's go ahead and that's nice and tight, no stray inductance. Okay. All right. I already had some. I'm going to insulate that from the relay. Just like that. That'll make that strong. We're going to take a little piece, and it's going to go on this wire. Well, it was. Now, before we can hook all this up, I'm just getting it all laid out. And that's the bottom, the black on it. All right. And then that's our SO239 connector. So now, we got that ready for when we do put it back. We need to go over here and check. I'm going to use this cabinet. We're going to check the transistor. I just wanted to get everything. And then we're going to reflow all this. All right, there's a coupler. Oh, but damn, we got a bad solder joint right here. I'll be damned. I'll be damned. So on our coupling shunts, we got one loose. Make sure these aren't loose. Our pins are tight. Good, both of our pins are tight. We're just going to tighten up these pins. And we're going to look to see which one's the shortest. Okay, it goes just like this. There we go. Now we go. All right. That's good. Now, we're going to have to go to our other gun. We're going to lift the easiest leg that doesn't have any components tied in with it. That will be, we're going to have to remove two of them. So we'll move the emitter and the collector leg, which will be right here. Collector, emitter. We'll turn that down. And I'm going to go to let's go. Getting a little traffic now. Alright. Alright. So we're going to remove these two. Find out which two would be the easiest. Should just be able to lift that. Alright. It's got all the identifiers. EVO, pretty cool. Just letting the gun heat up, guys. Lift this base. The right tool for the job. Right there. Alright, once that gun gets hot, we'll be good to go. We're going to lift the base. Base in the collector. And then we'll test and see if the transistor is any good. If the transistor's any good, then we'll put another one in it. All right. So, quite a bit of solder on this, so I'm going to be able to suck most of it. Good. All right, folks, so that's how you lift a base on a reverse transistor. So you see we got the base lifted. Now we're going to come over here and lift the collector. And by doing so, you can come in here just like that. Remember to use a good solder gun and the proper equipment. So now we got the collector, the base, and both of the emitters are still on the board. Oh, now we got another problem. We just broke off our feed wires. I've got to rebuild these. I've been putting it off, putting it off, putting it off, putting it off. I'll go ahead and just do this one right now so we can. So we got to use this hot gun and tin up the wire a little bit there. Like that. And then what we'll do, put a little bit of heat shrink on it. And we're just going to do that temporarily so we can continue to work. But I've got, oh my God. I just dumped all my heat shrink. Again. I mean, how in the hell do I do that shit? All right. Get this broken leg off. There we go. The broken leg out of there, and then we'll put our new leg in. Try to hold this because I've been using these. See, they get so brittle. Why do they do that? I wish the United States would start making something with some quality again. Like, Jesus. All right. Dog. Just a dog. You're just a dog. You're just a dirty old dog. Aren't you? Just a dirty old dog. Uh-oh. 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 Looks like I was right from the get-go. Well, that's good. This means we'll go ahead and jerk this transistor plumb off the board, but we're going to run it. I always test 3-4 times. Now, this is an auto gate tester, so it does not matter how you hook them up. First time I hooked it up accordingly. Now I'm just reversing just to check all gates. Okay, we have a shorted transistor, guys. So we're reading diode one way, and we're reading a dead short the other way from collector to emitter. And then we got base, collector, emitter, period. We have a diode that way. Okay, so the transistor is bad. So now we'll remove it. And I thought it was. That's why you didn't see me put the amplifier back together. I had a feeling that was going to be what happened. Alright, so now what do we do? Well, we're going to turn the gun back on and we remove the transistor completely. And I'm going to put the collector is always at the top, so you guys that are learning, I want to show y'all. Because see, this is reverse mounted. See how it's soldered? No. It's quite a bit different setup. It's just soldered on the opposite side of the board. So your collector is obviously, I just write it out for. So you put a C at the top that way, and then you can put you got a C back here, so you don't install it wrong. But what you do difference is you solder it, but you have to push the transistor away so it doesn't come up flush. I just have to show you all what I'm talking about. You got to bend the feet opposite. Letting the gun get hot again, guys, is all I'm doing. We'll stick this, have to see exactly what the gains and the characteristics of this device is supposed to be. Pull up a data sheet. It's a 2105, SRF 2105 Motorola. There we go. It'll go out now. Just like that. But anyways, basically you solder the tabs down and then you push the transistor in. Therefore, it gets that reversed effect like you see here. It's a little bit tricky. Alright guys, so now we're going to come in here and we're going to remove both emitters. So there's one. There's two. I'm going to clean each stroke, each pad. Just like this. like that. We're going to keep the transistor just like it is because we use this as reference when we go to solder the next one in, because we got to bend the pads down and reverse. Hopefully it makes sense, guys. It's not hard. You're just doing it like this. You're bending the pads up instead of down. That's all there is. That's all you're doing. I'm going to go ahead and clean this off. Just like that. I'm going to clean all this shit off this pill. Shut that off. We're going to let that sit, cool off. This is all the solder that come off of those pads. I'm going to go get rid of it. Now we're going to take the transistor and put it back in the tester. First, we're going to clean this deck. Or this pallet. Just like that. Awesome. So we got all our leads ready. Tuned induction. Induction tuning. I like that. So cool. Good board. Good prominent traces. All right. Alright, so if you see, it's reading a resistor that way. This is a way you can look at the faults, is what we're doing. Should have a diode reading them one from this direction. Typically what happens is they go to diode, or I'll show you. So there's your damaged component. Now we should have a diode. Check it out. blown that way. I'm checking all my gates just to see if my something oops. I forgot to move that around. My bad. Oh, my hands. This is my weakness, guys. There we go. Remember what I just told you? Remember what I just told you? Have a look at your screen. So that's telling you what the transistor did when it fell. It went into a diode mode. Basically, it's reading as a diode. This is exact characteristics of why we can't get RF through the amplifier. It won't even pass. Just a dead brick wall. So now we're going to go pull a data sheet on a 2105 Motorola, because I don't have it off the top of my head, but I think it's a 60 watt device. It might be a 75 watt device. But we're going to find out what we can stick in. Try to stick something in here and make it work. I got a few things we can use. There's an old 2290. Let's see what this 2290. Now we might not be able to use this because of the tab situation. That's what's going to be kind of tricky. We'll want to try. See, I've got this one's still got good gain on it. So actually, I might be able to. Gonna have to measure the distance from this other rise. But I don't. This one here, because we've cut the tabs off. I'm just saying if it would lay. I actually might be able to make it work if I wanted to use it. Oh yeah, it's gonna work. It's gonna work. That will work, absolutely work. I just need to make sure that it's compatible, but I just making sure I had enough tab. And it does. Because reverse, I can get enough on that tab. Let's see what the HFE looks like. I think it's in the 50s. I think it's in the 50s. Let's see what we got. So. Oh, my hands, guys. All right, I'm going to hold it now. And let's see what we got. It popped off. So this is the 2290 spare. We're just texting Toshiba. And this one might be bad. I don't know. I didn't exit. I'll tell you one damn thing. My damn hands. I'll be down. This is the bad one I should have marked. I'm going to test it again, but it's showing it's bad. Probably is. It's probably why it's not in the freaking my bench or in my container, but I don't understand why I didn't mark it. I don't typically do that. Oh, my hands, man. See, my hands got plates in them, guys. Both of my wrists. And I can't use them like normal people. Oh, they don't bend and work. And it's all a big pile of shit. But I'm alive. I ain't supposed to be, so. A head-on motorcycle crash. There's 3 different tests and they all read diodes, so I don't understand why I did that. Maybe I know what I did. This one's good, this one's bad, and I forgot to mark it. Let's see. There. See what we got right there, ladies and gentlemen. Now that explains it. Explains why they're in the dish. Oh, my hands. I don't like using longer leads because stray inductance and shit. Makes me mad that I didn't mark these, to be honest with you. Yeah, it makes me mad that I didn't mark these. I took these out of the amplifier I just rebuilt. Both of these are bad. Where's my marker? Now I gotta go hunt down a transistor. X. X. Now I'm gonna go find the transistor here. I guarantee you I got some. Oh hell. I should have some. I think this is a bad one too. Oh, I know where my good ones are now. I just remembered. Now here's a pair that I'm saving. There's a 455, I believe is. won't use that. Here we go. We should have several things we can use here. I don't want to use that 455 micro. It is a high gain component. Let's see what it looks like. And then I've got my 2290 for my backup for my drivers. That's got 66. 66. Let's test that one. So I know these are good. These are my babies. Let's start with this micro. Which I'm not going to use, but I know it's going to be around 60s. I won't save them if they're not like in the 60s. I mean, I'll save them, but I don't. This is going to be a pain in the ass, guys. And it's just because of my hands. That's all it is. Oh, you fucking bitch. Oh, goddamn shit. I've got to make up some new leads. I'm fucking so done with this shit. Usually I can hold this and it won't jump out of my damn hands, but I'm going to be a crawdad today. Yeah, you're shorted. See? That's what I gotta do. Bars are not allowing me to do what I want to do. All wanting to fight me, wanting to run away from me. Yeah, we got something wrong. I know for a fact. Oh. I made a mistake, guys. I made a mistake, and I'll admit it right here. I had 2 leads hooked up in pin 1, so that was a complete mistake. Y'all hearing what I'm saying? Complete mistake. So none of those tests were accurate. 2 of them transistors are good that I said aren't good. And I knew they were. They wouldn't be in that bowl. When a transistor is bad, it doesn't stay around. So that's what was tripping me out. I've got wires trying to break here. Alright. We got it now, though. Watch this. I knew something wasn't right. I was like, what is going on? Alright, so let's go back to this one here. I know it's good. Let's go. This one here has got like, I want to say it's got like 8. It's pretty low. I was like, what in the hell is going on? I have got to redo these leads. Look at this thing fight me. Biggest part's it's my hands, but like literally. All right, so 8, around 8. Okay, so much better than I thought. So HFE of 30. So that one's good. And like I said, I want to make sure all these gates are good. Oh man, my hands are driving, they're hurting trying to do this shit. So we can. Can you believe it, guys? I mean, can you believe it? $32. All right. Go through all these again. So this is definitely good. Do we want to use it? Probably not. And this is my good girls. This is the one that we first started off with that I know is good. It's low, though. I think it's got like 5. Let's see if I'm not right. That makes me so mad that I did that. But hey, man, everybody is human. But I knew something wasn't right because we was getting too many false readings. So I had to go look around and see what was going on. Come over here and get this side of it. Hit it again. Should be a low number. Okay, 5 exactly. Just like it's marked. Absolutely. So, that's a little too low for my liking. But it is a good transistor. Now, here's the ones that are marked out. And I'm afraid that I marked this one and it shouldn't be marked. I'm going to have to unmark it. Let's see if it's good. Pisses me off. Now we're going to go down here and grab this. Now we're going to grab Are you serious? Take a deep breath. Set it down. Let's see what we got. I'd like to use this guy if he's got some decent HFE. Uh-oh. Okay, this one is bad. This is me. I get so scared of this thing because that right there. Make some fresh ends here. No big deal. This one's still pretty good. So that's in gate 1. Gate 3. And gate 2. All right. This one I know is 66. This one goes to my 1x2. It's my backup transistors for my 1x2. Oh, that's got a big glob of solder on it. That's why it won't connect. Yeah, all these are full of solder. I swear to God, man. I swear, guys, it's that damn hard to do this. Especially when your damn clamps won't clamp to your tabs. They're all wore out. All right, that one's 68. So it's actually reading 2 points higher than what. That's going back in my... right here. So this is for my backup, and then these are both my 2879s, and they're in their 80s. All right, so that's that. Well, that'll go up. Now, this is the one that's marked 5. This one is good. So we're going to have to make a decision here. Because now I'm starting to question. Check this out. Check this out. So, if this is good because we cross the lead, okay, that's what I thought. It ain't good. It's definitely bad. Good. So we're 1, We're in 2. We're in 3. Good. So that's definitely bad. We're going to run this. Trying to get a rhythm going here. These damn tabs are fighting me. See? That one's bad. It's got an X on it. So, all right. So we got a 16 DOA HG that's got an X on it. Pretty sure it's bad. I just second guessing myself because of I had the tester crossed. Had 2 pins and 1 leg. So I just want to make sure that I am not overlooking a transistor that's good before I move on. I have to, because this shit costs too much money. Okay, that one's a diode. That one's junk. It's got an X on it. And the 455 high gain. It's got 8 marked on the back. We're going to put it back in. Now that we're getting a good flow here, I figured out what pins work in what position here. So now we're going to run this high gain MRF Motorola. Purple dot or blue dot. And it's got 34 HFE. And then we got our nutcracker Toshiba. Says it's got 5 on it. And I've got exactly 5. So the transistor's good, but the gain's awful low. This one's 38, and it's a micro. And I don't know. The surface area. I actually think I can make it work. We might have to, and the tuning should be fairly close. I don't know if that's, you guys understand what I'm trying to say, and I think this might work. Absolutely. This is gonna, we can probably make this work. Now I'm gonna go look, I have to shut the video. SRF 20, let me write this down. I gotta look on the data sheet, see what is compatible with it, and what I can make work. I have tuning capacitors on the, so I should have a pretty good range to be able to tune the circuit. And this one's good, and this one's bad. The one I'm took out of it. All right. Diode. All right. Just wanted to make sure I don't have any transistors in the wrong place. All right. Now I'm gonna go look at some data, some cross references. I'm not going to use this 5. Oh, I need to mark this 5 off. That's the one I marked. And it's still good. 5 got 5 HFE, which is low, but it's still good. And I might even use it here just to play if I need to. Because even though it's HFE of 5, it can still make 100 watts. It might take a little bit more drive because of the gain characteristic. But, okay, let me go look some stuff up. That's a 21. I don't know why I keep getting so. Here it is. 2105 that we want to look into. Be back.